Barry, you're up on deck. But first, Cormac, Kikkert with... You removed a word from your front slide. This one says simple on it.
Yeah.
His doesn't.
Hey guys, I'm Cormac Kikkert. I'm a grade 12 student at Gungahlin College, and I'm competitive. Well, just a bit. Yeah. So 2 years ago, back in grade 10, we had a final project coming up, and I wanted to do something crazy in order to beat everyone else. I wanted to make a 3D physics engine in Python. So Python actually makes this really easy. There's a ton of useful libraries that you can use. So for example, there's PyMonk. This can be used to do the 3D physics simulations. PyOpenGL can be used to render the 3D environment. And Kikkert can be used to build the GUI for the application. However, why use all these fancy modules and libraries when we can just use Pygame? So for those of you who don't know Pygame, it has some nice features. There's no physics simulations capable in it. You can't do any 3D rendering. There's no GUI framework. But you can draw triangles and lines. So I'll just quickly showcase my thing. So here's the game. You can move around in this 3D environment. Ooh. And you can build stuff by just clicking on points and pressing build. So yeah, so before I actually show the physics simulation, I just want to explain how it works. So I guess the fundamental building block of it is the point. So the point is just two vectors. There's a position vector, which is the green circle in it, and there's a velocity vector, which is the pink arrow. So in each frame, you calculate the velocity vector and you add it to the position vector, like that. This is pretty simple, but you can make it as complicated as you want. So for example, if you want to simulate gravity, you could have a vector going downwards and just add it to the velocity each frame, like that. Or if you want to simulate collisions, you could flip it on the vertical axis or something, like that. So this is fine, but it only really allows us to simulate points moving in a 3D environment. So what if we wanted to simulate more complex objects, like a cube or a pyramid? This may sound really difficult, but it's actually pretty simple. So first we just break down the object into triangles, which is pretty easy to do. And then we just split it down further into sticks, or lines. I just like calling them sticks. So each stick in my simulation is just a line and then 2 points. So the line just represents how far the points should be from each other. So we do the same thing as we did before. We calculate the position vectors and the velocity vectors and just add them, like that. And then we just readjust the points to make sure that they stay the same distance from each other, like that. And we do this 10 times a frame for each stick in the simulation. And this relatively simple process allows me to do stuff like this. So I'll just try and open it. So yeah, here's a fabric, and as you can see, you can move it around, and it behaves pretty realistically. Yeah, thank you.
That all?
No,
Is that still going?
yeah, so that's pretty much it. But
No, the other right-hand side. Keep going.
Oh yeah. So my GitHub link is on my screen. Oh yeah, there it is. So if you want to see the rest of the code, because I didn't actually explain how to do the GUI or the rendering, so if you want to see it, you can click that link or type it in, whatever. And yeah, anyway, thank you for listening.
If anyone wants to come up and click on the screen later, there'll be an opportunity at the end of the lightning talks. Thank you.